Welcome back to another explainer. Today, we're diving into what I like to call a mathematical cheat code for geometry. I'm absolutely thrilled to guide you through this because, let's face it, we all love a good shortcut, especially when it's rigorously backed up by mathematical rules. We're going to uncover a secret that is going to save you an immense amount of time and effort. I mean, think about the question right here. What if I told you that you could prove two triangles are exactly identical, but you only have to do half the actual work? Imagine cutting your workload down by 50% and still getting the exact same mathematically flawless result. Sound kind of like a scam, right? Well, in the realm of geometry, this isn't just a fantasy, it's a fundamental theorem. And today, we're going to unlock that very superpower. Here's our game plan for today. We'll start with the basics of shape congruence, then move on to triangles and their 6 elements. After that, the main event, the SSS shortcut rule. Then we'll put it into practice solving example 3, and finally, wrap up with a try-it-yourself challenge. Let's get moving. Part 1, Basics of Shape Congruence. So, the mathematical term for identical twins in geometry is congruence. Congruence basically means two geometric shapes are exactly equal in size and measure. If you picked one up and slapped it right on top of the other, they'd overlap perfectly. Nothing sticking out, no missing edges. And if you spot that symbol, the equal sign with a little squiggly line on top, that is geometry screaming at you, hey, these two things are exactly the same. Now, at the most basic level, congruence is super straightforward. For two line segments to be congruent, like AB and CD, they just need to be the exact same length. If one is 3 centimeters, the other is 3 centimeters. Boom, congruent. It's that simple. And for angles, same deal. They just need to have an equal measure. If one angle is 50 degrees and the other is 50 degrees, they're congruent. Easy enough, right? But here's where things get a bit tedious, when we step up to larger polygons. To prove two big shapes are congruent the traditional way, two very strict conditions have to be met. First, every single pair of corresponding sides must be equal in length. Second, every single pair of corresponding angles must be equal in measure. If you're looking at those pentagons, that means verifying 5 pairs of sides and 5 pairs of angles. That's 10 separate elements you have to check and match perfectly. It is honestly exhausting just thinking about it. Which brings us to part 2, triangles and the 6 elements. 6. Just burn that number into your brain for a second. A triangle is a polygon with exactly 6 distinct elements. Can you guess what they are? Yep. 3 sides, and 3 angles. That's the whole shebang. So, if we did things the old way, proving congruence would mean verifying that all 6 of those elements match their partners on another triangle. But here is the brilliant revelation. We don't actually have to do that. The new way proves that it's entirely sufficient to check 3 specific elements, as long as one is a side. We're literally slashing our required work in half. Let's dive into exactly how that works in part 3, the SSS shortcut rule. This brings us to our very first shortcut for congruent triangles, side, 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 or SSS for short. The rule is beautifully simple. It states that two triangles are congruent if each side of one triangle is congruent to its corresponding side on the other triangle. Notice those little hash marks on the sides of the triangle shown here? 1 hash mark means those 2 sides match. 2 hash marks mean that pair matches. 3 marks, you guessed it, they match. Since all 3 pairs of corresponding sides are equal, we can conclusively say, without a doubt, that triangles are congruent. I really want to pause and emphasize just how much of a game changer this is. If 3 sides match, the triangles are congruent, period. No angles required, we completely skip measuring the angles. By just proving the skeleton, the 3 outer borders are identical. The laws of geometry guarantee that the angles locked inside are also totally identical. You get the angle proofs absolutely for free. Let's see this in action. Part 4, solving example 3. Okay, let's put our detective hats on. We've got a figure here that looks kind of like a kite, split down the middle into 2 triangles, one on top, one on the bottom. The goal? Proof they're congruent. Step 1, the problem hands us our first clue, showing side AD is equal to side CD. There's our first side. Step 2, it also shows side AB equals side CB. Awesome, that's our second side. But wait, we need 3 sides for the SSS rule, and we are completely out of given clues. So step 3 is where we do a little digging. Check out that line running right down the middle, line BD. That line is the bottom of the top triangle, and it's the top of the bottom triangle. It's a shared common side, which means obviously it's equal to itself. Boom, there's our third side. Side, side, side is complete. Now for the really cool part. The second half of this example asks us to find the measure of angle C. Well, the diagram clearly shows angle A is 100 degrees, and since we just used our SSS rule to prove beyond a shadow of a doubt that these two triangles are identical twins, we instantly know every corresponding part is equal. Therefore, the measure of angle C has to be the exact same as angle A. Without touching a protractor, without doing any crazy algebra, we instantly know angle C is exactly 100 degrees. That right there is the sheer power and efficiency of the SSS shortcut.
Finally, Part 5, Try It Yourself Challenge.
Before I hand over the reins, let's do a super quick rapid-fire recap so this is totally fresh in your mind. First, congruent simply means geometric shapes are exactly equal in size and measure. Second, triangles have 6 total elements, 3 sides and 3 angles. And third, the SSS rule is your new best friend. It's a powerful shortcut that only requires finding 3 matching sides to prove total triangle congruence, giving you those matching angles completely for free. All right, here is your mission. Check out this final figure. We've got 2 triangles meeting in the middle. You're given 2 pairs of matching sides right off the bat, plus a huge clue about a midpoint on the bottom line. Your task is twofold. First, use the SSS rule to prove these 2 triangles are congruent. Second, find the missing angle measure by using the algebra provided in the diagram. Can you spot that hidden third side? And once you prove congruence, how are you going to use those identical angles to solve for x? I'll let you ponder that puzzle. Thank you so much for hanging out with me for this explainer, and good luck unlocking the rest of this geometric mystery. See you next time.